Hello students, welcome to the Turito School Foundation program. Today we are going to deal the very important topic related to the ninth class students, right? Right. That is going to be, maximum height, time of ascent, time of descent and time of flight. We would like to go for this one. So you were having that one special case, a body which is projected vertically. Yes, you wants to measure that vertical displacement. All right, that is nothing but the height. When do you say it is going to be the maximum height? Yeah, it's very clear where that it's a final velocity. If you have been projected a ball, if you have been projected an object into the air in a upward direction, just it will reach the maximum height. Okay, how long does it will reach that highest point? Where its velocity is going to be 0. After that it will change the direction, say yes or no? Yeah, at the maximum height its velocity is going to be 0, its final velocity. We would like to talk about that. It has been projected with an initial velocity. Alright, after some time it will reach the height. Okay, so it will reach the height, and if the final velocity is going to be 0 at a particular point, so that the vertical displacement is going to be the maximum height where its velocity, final velocity is going to be 0. It's very clear. We can get. Yeah, it's very interesting. The time of ascent and time of descent are going to be represented. Time of ascent is equal to time of descent. It's very clear. All right. Easily we would like to go for this one. Right. Everyone has to go for this one. So maximum height, where you are going to get that maximum height, it's going to be projected here. So it's a final velocity v is equal to 0, right? This is going to be h maximum. All right. Okay, yes, time taken to reach the maximum height, it's very clear. So time taken by that body, that is going to be Ta. Yes, it's very clear, h maximum. What about the time of descent? Time taken to reach the ground. Yes, this is at maximum height. It's going to reach this one. This is going to be Td. Time of descent. Time taken by the body to reach the ground or point of projection from that maximum height. It's very clear. Okay. What about the time of flight? We would like to go for this one. Time of flight. Just we have to. It's going to be the time of ascent plus time of descent. And one more thing you can know about this time of flight, the time spent by that projected body in the air. The total time for the projected body which remains in the air from that point of projection to that terminal point. It's very clear. It's going to be getting that. If you are going to get this one, so yeah, this is going to be time of ascent and time of descent. It's very clear. So time of flight, just we have to take that. This is going to be time of flight. Very clear, we can go for this one. So time of flight Tf is equal to Td plus Ta. Very clear, we would like to go for this one. So let's have that. All these are going to be having the simple discussion, but we would like to discuss with that animated videos and well crafted methods are there. No? For you, you can feel better. You have to understood that matter what I am going to convey. Right, it's very clear. Let's have the look into that matter. Please, these are all known as the motion parameters. A body projected vertically upwards. It's very clear. Let's have the look into that matter which is going to be projected. Yes, it's very clear. We are going to consider that the motion which is going to be along one direction. Yes, everyone has to see it is going to be one direction. Just you have to see this one. Yeah, it's going to be getting that. Yes, this is going to be 1D motion, 1D. Just you have to take this one. It's very clear, very clear. Yes. Okay, does it has been reached that you have to say this is going to be h is equal to h maximum. Yeah, this is going to be the maximum point. What happened is final velocity becomes 0. T is equal to 0. Okay, how you can understood that matter? Please let have that. In case of a projected body where its final velocity is going to be 0, that is the maximum height. All right, it's very easy for you. It's going to be projected body. Yeah, we are having that at that point its final velocity is 0. It will changes its direction. That is the consequence. All right. After getting the 0, it will come back. It will return to the same point of projection. It's very clear. But you need to know about this 1D motion. It's very clear. In case of that oblique projectiles, just we would like to, in a higher classes you may get that it has been projected at an angle. Yeah, you have to get that angle also. Projection of angle is going to be considered. Okay, let's have that 1D motion. It's going to be getting that. It's a vertical displacement. What this is called? This is the vertical displacement. So, the vertical displacement of your body where its final velocity is going to be 0. That is nothing but maximum height. Very clear. We would like to go for that. So, by getting this animation, what we have to derive? Right. Okay. We know very well about this one, right? Yeah, what is the expression for maximum height? Maximum height. You have to confirm that is going to be h maximum. Easily you will find out this one. This is not a big task for you. Okay. We know that equations of motion, that is going to be v square minus u square is equal to 2a(s). This is very clear. If v is equal to 0, yeah, you have to take that a is equal to minus g. It's very clear. Yes, which is going to be projected in upward direction. Right. Okay. You can confirm that if v is equal to 0, then what we can take that s is equal to h maximum. All right, it's very clear. Where does it reaches? If that final velocity is going to be 0, it's very clear. We would like to go for that h maximum. So, easily you will find out that u square is equal to 2 into minus g into h maximum. It's very clear. We would like to go for that maximum height. Yeah, u square by 2g. Very clear. We would like to go for this one. Have the look, and we would like to confirm that maximum height is going to be depend on its that initial velocity of that projected body. With what initial velocity does we are going to project. It's very clear. If you are going to get that g value, it's going to be fixed on that space. Yeah, you have to get this one, right? It's very clear. With what velocity does we are going to projecting that body in vertically upwards, right? Let's have the look into that matter. Easily we will get that, right? We have to show that this is going to be maximum height reached. That is going to be u square by 2g. Very clear. You are all going to know about this one. Yes. Have the look into that matter. Maximum height reached by the body, which is going to be h is equal to u square by g. It's very clear. It is going to be having some initial velocity. You have to get that. All right. Time taken to reach the maximum height. This is going to be time of ascent. It's very clear. We would like to go for this one. Time of ascent. It's very clear, right? Yes, it's going to be time of descent. Right. Okay, we would like to go for that. Time taken to reach the maximum height. Okay, time taken to fall back down. into the same point, to the same point, yes, where it has been projected from where. Just you have to see, these are all going to be getting that time of ascent is equal to time of descent. We would like to talk about that, right? And we would like to get this expression also. Yeah, it's very clear. A body is projected upwards. The vertical displacement, it's going to be getting that the vertical distance or displacement we would like to. In case of 1D, we would like to talk about the distance and displacement, both are going to be equal. It's very clear. Now, we would like to go for that. For a body projected upwards, vertical displacement from that ground about which its velocity is 0. That vertical displacement is called maximum height. It's very clear. We would like to go for that. Right. Time of ascent, just you have to see this one. Everybody has to look into that matter. Right. Just you have to. Everyone has to look into that matter. Time of ascent, time taken by the body to reach the maximum height. That is going to be the time of ascent. Yes, you are going to get this one. From this point, just you have to see, this is going to be right. This is very clear. Yes. Yeah, this is going to be TA, that is time of ascent. It's very clear. We would like to go for this one. Time taken by the body to reach that point. It's very clear. This is going to be the H maximum. Yes, or maximum height. Yes, we have to see this one. So, the time taken by the body to reach the maximum height, it is very clear. We would like to get this expression also. Very easily we will get that. Yeah. We know that equation of motion V is equal to U plus AT. It is very clear in upward motion. Let us assume the body which is going to be in upward motion. We would like to apply that equation of motion, right? Yeah. Here V is equal to 0, all right, it's very clear. And A is equal to minus G. It's very clear. We would like to consider this one. All right. So, 0 is equal to U. It has been projected with that initial velocity. U is not equal to 0. Yes, we have to consider this one. So, minus G T. Yeah, it's going to be T. Here, T is equal to U by G. Right, time taken to reach that maximum height, just we have to take that T, yes, if V is equal to 0, we are going to get this one, it's very clear. At maximum height, we are going to get that is going to be time of ascent. So, since T is equal to TA and V is equal to 0, H is E, just we have to take this one. You are all going to identify all these parameters, just have the look into that one. We would like to go for this one, all right. Yes, you need to go for that. V is equal to U plus AT and T is equal to TA, time of ascent. It's very clear. We would like to go for that one. Yes. Easily we would like to, yeah, here also TA, it is going to depend on, yes, U and G. I depend on two parameters, just we have to get this one. So, we would like to go for that next one. Let us have the look. Yes, you have to get that for a body projected upwards, the time to reach the maximum height is called time of ascent. It is very clear what we have discussed. Now, it is time to discuss about the time of descent. We would like to go for that. From that maximum height to reach the ground or point of projection, the time taken by the body to reach the point of projection from that maximum height, that is going to be time of descent. Just we have to take this one. Let us have the look. Yes, it is very clear. Just we are going to find out this one. It's very clear. Just you have to see time taken. Just you have to confirm this one, right? Time taken by the body to reach the ground from the maximum height. Yes, we would like to go for this one. Time of descent. If it is very clear, a body projected upwards, the time taken to travel from the maximum, it's going to be very clear, the time to travel from maximum height to the point of projection on the ground, it's called time of descent. It's very clear. So while you are talking about the time of ascent and the time of descent, we would like to go for that motion in towards upward direction, downward direction. Yes, you have to confirm time of ascent. It is while you are talking about time of ascent, you need to take the consideration of motion in upward direction, motion in downward direction. We have to take that. Yes, it's very clear. At the point, at the maximum height, its velocity is going to be 0, but you need to consider its acceleration is not at all going to be 0. It's very clear. It is going to be in the opposite direction. It's very clear. Yeah, right. You have to get that time of descent. Just you have to get this one. It is related to downward motion. It's very clear. What about that time of ascent? Yeah, it is related to upward motion. Just you have to get that. It's very clear. We would like to talk about that. Yeah, this is the case. We were good. Right. It's very clear. This is going to be TA. Yeah, it's going to be getting that. This is going to be TD. It's very clear. You are moving in upward and downward direction. It's very easy to have the derivation. So you would like to talk about that TA and TD. U by G. It's very clear. Let's have the derivation part. Yes, for upward motion, we would like to go for that upward motion. Let's have the look into that matter. Very clear, we would like to go for this one, right? Yeah, you are going to get this one. It's very clear. Yes, you have to take this one, H maximum. This is going to be U square. Yeah, you can take that. So this is the equation of motion we are going to consider. Now we would like to take that at maximum height, since you would like to go for this one. Yeah, at maximum height, V is equal to 0. Very clear. Just you have to get this one, and getting this, and yes, we have to take that. Yeah, we have to take the sign also. It's going to be minus G. All right, we would like to get this one in upward direction. Yes, you can get this one. Basically, we are having that V square minus U square is equal to 2AS. Very clear. we would like to go for this one, right. Yeah, while you are talking about that final velocity, where does it reach the maximum height? So, its final velocity is going to be 0, it is very clear. Now, you have to get that, yeah, you have to get that at S is equal to H maximum, yeah. V is equal to 0, then S is equal to H maximum. It's very clear, you have to confirm this one, that is nothing but vertical displacement, and also we will have to consider A is equal to minus G, alright. So, we have to get this one, this is the basic equation 1. So, from equation 1, we would like to go for that, that is V square, that is equation 1, 0 square minus U square is equal to 2 into minus G into H maximum. It is very clear, you will get that H maximum is equal to, for forward direction just we have to see, this is going to be that U square by 2G, right. Okay, it is better to have the look into that matter. We have been divided in the two cases, that is going to be getting that in upward and downward motion. Just you have to see while you are going to get, right. Forward, for downward motion, just you have to take this one, it is very clear. Yeah, you know very well about that. That equation of motion is going to be getting that S is equal to ut plus half at square. This is very clear. Alright, you can have the look into that matter. For a body projected upwards at maximum height, the velocity becomes 0. This will be considered as the initial velocity of that. Yes, you have to see, that is very clear. Yeah, if it is going to be reached that maximum height, alright, it is going to be very clear, but it is reaching the ground, yes, it's V is equal to 0, but in downward, in case of the downward motion, what happened? It's U is initial velocity is equal to 0. This is nothing but U is equal to 0. We have to talk about that. V, it is going to be taken as 0. So, initial velocity is going to be 0. It's very clear. We would like to go for that. Is 0. Yes, you have to take this one, right? Okay, we would like to go for that with a particular velocity, it will touches the ground, you have to confirm. It's going to reach the ground with a particular velocity. We have to get that its final velocity is going to be defined. Yes, very clear. But V is not equal to 0 in case of downward motion. Just you have to get that. We would like to go for this one. It's very clear. Right. Let's go for that application. Yeah, you have to get this one. This is very clear. Let's go for that substitution part. We would like to go for that. Yeah, here that initial velocity that is going to be 0, very clear, right. A is equal to plus T is equal to TD. Just we would like to go for that TD, time of descent. T is equal to TD. It's going to be reached. Just you have to represent with another color. Yeah, it's better to have that. Yes, you have to take that. It's, yeah, going to be get, and you can take that S is equal to H maximum. All right, even though in downward motion it has been covered the displacement, you need to talk about that S, it is H maximum. All right, now we would like to go for that situation, it's here the time taken by the body to reach the ground in downward motion, that is going to be the time of descent from that maximum height. It's very clear. Yes, you have to get this one, right? You know very well about this one. S is equal to ut plus half at square. We know the equation, but we need to go for that substitution, right? That is, this is equation number 1, right? U is equal to 0 in this case, yeah, and what we are having, A is equal to plus G, okay, and T is equal to TD, that is equal to U by G. All right, it's very clear. We would like to go for that. Later we can go for that. Okay, now it is easy for you, just you will get that H maximum, that is equal to 0 plus 1 by 2 G into TD square. It's very clear. Now you can get this you will get that TD is equal to U by G. If you are getting that TD square, that is going to be 1 by 2 G into, what about U square by G square, just you have to get this one, that is equal to 1 by 2 U square by 2 G. Yes, you have to get that U square by 2 G, that is very clear. This is the H maximum. Have the look, everybody has to see this one, what we are having that expression. Yeah, in general we are going to have that expression in downward motion, that is going to be from the maximum height to the point of projection, which is going to be identified, very clear. Now you can have that TD, that is going to be time of descent. We have to consider time of descent. Yes, everyone has to know that, this is very clear. In bracket, TD is equal to U by G. Very clear what we are having this one. This is very easy for you, right? We have been substituted, that is U square by 2G. So finally what we are having for downward motion also, H maximum is equal to U square by 2G. It's very clear what we are having that, right? Okay, we would like to go for that. Please have the look into that matter, just we have to see. All right, now let's go for another topic. Okay, what we have been derived this expression. Finally what we have, right, nothing, just we have to take that, this is very clear. Okay, we would like to go for that time of flight, just we have to see that. Yes, you have to go for this one. Yes, while you are talking about that time of flight, you have to take this one. It's going to be the time spent by that particle, that is projected particle in the air before reaching that, from the point of projection to the terminal point, which before reaching the ground, just we have to confirm. This is very clear. This is going to be the initial point, this is going to be the terminal point. Does it have that? Yeah, it's going to be like that. So we are going to get that this one. It's very clear. We'd like to go for this one, right? Okay. Yes. Yeah, that is going to be TF is equal to TA plus TD. Yeah, we would like to go for the TA up to this extent. We would like to, this is going to be TD. So you have to get that U by G plus U by G. It's very clear. All right, that's going to be 2U by G. Yes, what we are going to have. You would like to go for this time of flight. Just you have to take the time taken by the body to reach the terminal point. That is nothing but after reaching the maximum height, it has to reach the ground, all right. So, but it will changes the direction. It's very important. We have to get this one, right? Yes. Yes, yeah. Have you seen that? Time of flight for a body projected vertically upwards, the sum of time of ascent and time of descent is called the time of flight. It's very clear. So, it is the total time for which the body remains in air. It's very, very important. Keep in mind, just have the look. It is the total time for which the body remains in air. That's very clear. We would like to go for this one. This is going to be the point of projection. So, it's very clear. Yes. This is the projection point. This is P1 and P2. Yeah, we would like to get that total time remains in air. Yes, you have to take this one. We have to get this one, right? So, otherwise we can talk about the time of flight. We would like to get this one, time of ascent and time of descent. It's very clear. Sum of the time of ascent and time of descent. It's very clear. We would like to go for this one, right? Yeah, time of ascent, time of flight is equal to time of ascent plus time of descent. It's very clear. We would like to go for this one. All right. Right, you have to get this one. This is the expression that which has been identified, that time of flight T is equal to, yeah, this is going to be time of flight. Just we have to represent. So, TF is equal to TA plus TD. It's very clear. Yes, it's very clear. We would like to go for that velocity of the body on reaching the point of projection. Now, you were talking about that the velocity of your body reaching the point of projection. Okay, it's very clear. It has been projected vertically in upward direction. Yes, it's going to be reaching in this one. Yes, right. It will changes the direction. You have to talk about that. It's going to be in upward direction after reaching the maximum height, and it has to, every projected body has to reach the initial point. It's very clear. It's going to be that initial. It has to reach the initial point or ground. Very clear. Yeah, you would like to go for this one. Let's have the look into that matter. Right. Okay, everyone has to identify this one. Yes, you have to see that. Yes, yeah. Okay. Yeah. When does it will changes? When does it will change its direction? You have to confirm this one. Okay. Its velocity is going to be 0 at maximum height. Let's assume here it's going to be. So, this is the maximum height. Let's assume you would like to go for that. You have to consider the direction which is going to be in opposite direction. Yes. Yeah. It's going to be getting that. This is going to be u, this is going to be minus u. With the same velocity, does it reach the point of projection? But one more condition, that is in opposite direction. We have to get that negative sign. It's very clear. Let's have the look into that matter. It's very clear. All right, it's very clear. Yes, velocity of the body on reaching the point of projection, how it is going to be derived, it's very clear. Right, let's have the look. Let a body be projected vertically upwards with an initial velocity u, it's very clear. The body reaches the point of projection once again after the time of flight, very clear. Yes, it's very easy for you, you will get this one, right. While you are going to talk about this one, it's going to reach that same, yeah, we would like to get that time taken, that is going to be TF, time of flights. Okay, let's assume this one. Now we have to take that the body which is reaching the point of projection, we have to take that A is equal to minus G. It's very clear. Now you would like to go for this one, all right. Yeah, that is V is equal to U plus AT. It's very clear. Okay, and we know that is going to be time of flight in the duration of its journey. Just we have to get that TF is equal to U plus U by G plus U by G. That is going to be 2U by G. Already we have derived that. Okay, it is going to be V striking. Yeah, with what velocity does it strikes the ground? You have to get that V striking. Okay, we have to get this one. All right. Yes, easily we will solve this problem. Just you will get this one. We are going to apply this one. Yeah, it's very clear. Okay, let's have that look into that matter. We would like to solve this problem, right? You know, V is equal to U plus AT. It's very clear. Here we would like to take that, yeah, that is V striking, yeah, and A is equal to minus G, T is equal to time of flight, all right, that is going to be 2U by G, all right, we would like to get that. Just we have to see, this is going to be, yeah, you can take that T is equal to TF, that is going to be TA plus TD, that is U by G plus U by G, that is going to be 2U by G. Okay, all right, that is going to be U minus G into 2U by G. It's very clear. We would like to go for that cancellation. It's very clear. That is going to U minus 2U. It's very minus U. Yeah, V striking is equal to minus U. But in the same velocity does it reaches the ground, but negative sign indicates opposite direction. It's very clear, we can go for that. All right. Now let's have the look into that matter. That is very clear. We would like to go for that. Finally, what we are having, let's see, that is V striking minus U. Yes, you have to get this. That body will reaches the same height, and you are going to get that while it is reaching the point of projection, its direction of motion is going to be in opposite direction, and it is going to be taken as the same velocity, right? What that initial velocity which is going to be projected. It is very clear. All right. Yes, yes. We are all going to have the look into that matter. Okay, in this way we can solve the problems. Okay, students, we are all going to derive that all expressions with the animated videos. Please watch the classes and have that continuous effort. Thank you very much. Have a nice day.